Hello children. So today we'll do proportion part 2, continuation from the last class. So let's take some more examples. So question number 1, what is given? See, if 2x minus 1, 5x minus 6, 6x plus 2 and 15x minus 9 are in proportion, and find the value of x. So given these are in proportion, so 2x minus 1 is to 5x minus 6 is equal to 6x plus 2 is to 15x minus 9. It's given that these numbers are in proportion. So you know by the property of proportion, the product of extreme terms is equal to product of the middle terms, or you can write in a fraction and cross multiply also. So 2x minus 1 into 15x minus 9, product of extremes equal to product of the middle terms. So 5x minus 6 into 6x plus 2. So this is what we get using the product rule. Now remember, you have to find the value of x, so we'll simplify. So 2 into 15, 30x minus 2x into 9, 2 into 30x square, 2 9 is 18x minus 15x plus 9. So if you open the bracket, so if you multiply here, 5 6 are 30, so 30x square plus 5 2s are 10x, then minus 36x minus 12. 6 2s are 12. So simplify further, this 30x square can be cancelled from both sides. So minus 18 minus 15. So 8 plus 5 is 13. So 33x minus plus 9 is equal to 10 minus 36 is minus 26x and minus 12. Sign of the bigger term we write. So this will give you, you collect the terms, like terms together in one side. So minus 33x plus 26x, sign will change, equal to minus 12 minus 9. Okay, well 9 goes, that's it, become 9. So minus 33 plus 26, so 13 minus 6 is 7. So minus 7x equal to 9, 10, 11. So this is 20 minus 21. This implies x equal to minus 21 by minus 7. So therefore x equal to, this cancel, this will go 3 times. So x equal to 3. This is the answer. Okay. Now another type we take, that is question number 2. Now question number 2, find two numbers such that mean proportional between them is 28 and third proportional between them is 224. We have to find two numbers. So let the two numbers be x and y. So now it's given that the mean proportional is 28. So therefore mean proportional is, or you can write equal to, mean proportional is equal to 28. Now you know the formula of mean proportional. So when A, B, C are in continuous proportion, B is the mean proportional, it is root over AC is the formula. So mean proportional between mean proportional is this. So mean proportional between x and y is root over xy is equal to 28, because mean proportion of xy is root over xy. So if you square both sides, so you get xy equal to 28 square. Okay. So that is 28 into 28 you can write. So that means here the value y is equal to, you can write y equal to 28 into 28 divided by x, equation number 1. Now you are given third proportion is 224. So that means third proportional is equal to 224. That means x, y and 224 are in continued proportion. So therefore, you know x by y is equal to y by 2 to 4 you get, because ratio of x to y is equal to ratio of y is to 224. So this implies y square is equal to 224x. Okay, so in this case you can actually find the value of x here and substitute the value, so that will be easier. So we interchange these two. So we write x here and this is y. So y will come down. So it will be easier to replace the value. So equation number 2. So therefore, from 1 and 2, from two equations, what we get? Y square is equal to 224 into, now x equal to what you got? 28 into 28 by y. So if you cross multiply, you get y square into y will be y cube is equal to 224 into 28 into 28. Okay. Now to find y, we find the cube root. So for that you factorize 224 first. 224. So 2 will go 2 times. 2 will go here. 2 5s are 10. 2 6s are 12. And 2 will go 2 2s are 4. 2 8s are. So 220 is already there. So what we get here, y cube is equal to 2 into 2 into 2 into 28 into 28 into 28. So to find y, we take one factor out of every three factors. So you get 2 into 28. So that is, it is 56. So value y is 56. Now we'll put the value of y in equation 1 and find x. So therefore, from 1, x equal to 28 into 28 by 56, because the value y is 56. So 28 will go here 2 times, 2 will go here 14 times. So x equal to 14. So finally, therefore, the required numbers are 14 and the other number we got is 56. So these are the two numbers. Okay. Now we'll take question number 3. Now in number 3, you are given three ratios equal, as you can see in the question. X by A, so question number 3, what is given is x by A is equal to y by B is equal to z by C. So prove that x cube by A square plus y cube by B square plus z cube by C square is equal to x plus y plus z whole cube upon A plus B plus C whole square. So when three ratios are given, suppose each ratio to be equal to k. Suppose. So this will give you x equal to k into A. As you can see, you can write separately x by A is equal to k, gives you A will cross multiply here, so x equal to k you get. Similarly, y equal to kb and z equal to kc you get by cross multiplication. Write each ratio separately equal to k and you find the value of x, y and z. You see, x equal to k into A, y equal to k into B, z equal to k into C. So after finding the values of x, y, z, now we'll take left hand side. So LHS is equal to. So x cube upon a square plus y cube upon b square plus z cube upon c square. So this is left hand side. Okay, we'll prove LHS equal to RHS. So this equal to x cube. X is k, so x cube will be k cube a cube, because x equal to k, so if you write whole cube, k cube a cube we get, by a square. Similarly, y cube will be k cube b cube by b square, and z cube will be k cube c cube by c square. So here a square will cancel with this power, b square will cancel with this power, c square will cancel with this power only, not the base, c will remain. So here what is left? K cube a plus k cube b plus k cube c. Now as you can see, k cube is common. If you take k cube common, what is left? A plus b plus c. So this is left hand side. Now we'll take RHS and try to find the same expression. So RHS here. RHS is given x plus y plus z whole cube upon a plus b plus c and its whole square. Now same as what we did in the left hand side, wherever there are x, y, z, we will replace by the values that we have obtained here. So x equal to ka plus y equal to kb plus z equal to kc, and its whole cube, denominator a plus b plus c whole square, you write as it is. Now if you take k common here, you get k cube. When you write outside, it will become k cube. Then inside bracket a plus b plus c whole cube divided by a plus b plus c and its whole square. I hope you can understand here. K is common, so it is k into a plus b plus c whole cube. So if you separate, then you get k cube a plus b plus c whole cube. Okay. So now this a plus b plus c whole square will cancel with this power. So what is left is k cube into a plus b plus c. So therefore, you see left hand side is equal to right hand side. So it is proved. Okay, this is question number 3. Now we'll take another one. Question number 4. This is similar to this question. Question number 4. Given a by b is equal to c by d is equal to e by f equal to UK. So suppose k. Suppose is ratio to be equal to k. As before, we get a equal to kb. You can see a equal to kb. Then you get c is equal to kd, and you get e equal to kf, as you can see. Now for the same process, left hand side now, LHS is equal to left hand side. We have a cube plus c cube and its whole square upon b cube plus d cube and its whole square. So this is left hand side. So replace a, c and e wherever they are. So here a cube, so a equal to kb, so a cube will be k cube b cube plus c equal to kd, so c cube will be k cube d cube and whole square, as you can see outside. And here b, value b is not there, so b cube plus d is also not there, d cube and its whole square. Now take common. Here what is common? K cube is common. So k cube, if you take common, you get b square plus d square left here. If k cube you take common, b square left, k cube common, d square left. So then whole square is also there. Divided by b cube plus d cube and its whole square. Now you separate the bracket. So k cube square will be k to the power 6 and b square plus b square and its whole square. You get here b cube plus d cube whole square, and down also b cube plus d cube and its whole square. So this will get cancelled. So what is left? K to the power 6. This is what we get in the LHS. Now we try to get the same thing from the RHS. So let's write what is given in the RHS: e to the power 6 upon f to the power 6. Now we have value of e. So value of e is k into f. So e to the power 6 will be k to the power 6 and f to the power 6 upon f to the power 6 is given. So f to the power 6 will get cancelled. So what is left? K to the power 6. So therefore we got LHS equal to RHS. So finally LHS is equal to RHS. So it is also good. Now we'll take next question. Question number 5. Okay. Now question number 5. A, B, C, D are in proportion. Then prove that. You are given, what is given? A, B, C, D are in proportion. Given. So you know, if A, B, C, D are in proportion, so we can write this as A by B is equal to then C by D. So you can suppose this to be K again. See? So once again, as before, A will be equal to KB and C will be equal to KD. Now put the values A and C in LHS. So take LHS now. Left hand side is equal to, it is given A square plus AB plus B square upon A square minus AB plus B square. Put the value A equal to KB. So K square B square, because A square given, plus A is KB, so KB into B is also there, plus B square as it is, we don't have the value. So A square is K square B square minus KB into B plus B square. So what we have done is we have replaced A by its value KB. So B as it is. So here you can see B square, B into B, B square, B square. So we can take B square common. So what is left here? K square plus K plus 1 left. Denominator also B square is common. So K square minus K plus 1 left. So B square cancel. So we have K square plus K plus 1 and K square minus K plus 1. So this is LHS. Now let's simplify right hand side and try to get the same expression. So right hand side we have C square plus CD plus D square, C square minus CD plus D square. So we have the value of C as we did in the LHS. We put the value, we replace C by its value K. So C square will be K square D square plus KD, that's the value of C, into D plus D square as it is. Denominator with the same thing, K square D square, that's the value of C square, minus KD into D, value of C, plus D square as it is. So as you can see, K square is D square is common here. If you take D square common, so what is left? K square plus K plus 1, and here D square common, K square minus K plus 1 left. D square cancel, so you get K square plus K plus 1 and K square minus K plus 1. So this is same as this one. So therefore LHS is equal to RHS. So this is good. Okay. Now we take question number 6. Now in number 6, this is ICSE question, came in the year 2010. So number 6, this is ICSE 2010. So the question is, if x, y, z are in continued proportion, so what is given? X, y, z are in continued proportion. So that means, so x by y will be equal to y by z. Okay, because continued proportion, so x by y will be equal to y by z, and suppose this is equal to k. So when it is continued proportion, okay, so since y is repeated here, so begin with the last ratio here, equate with k and find the value. So therefore write y by z equal to k implies y equal to kz here. First take the last ratio and equate with k. So y equal to k into z, kz. Then you take x by y equal to k implies x equal to ky. Okay, x equal to ky by cross multiplication. But as you can see, y is kz, so to put the value of y again. So it is k into kz, so it will be k square z. Now you see, we have expressed both x and y in terms of k and z. Okay, so you have to be careful when it is continued proportion. Okay, so everything you have to express in terms of k and the last variable here, last number z. Okay, so now take left hand side. Now process same. Left hand side, x plus y whole square by y plus z whole square. So this is equal to, now put the value of x and y. So x you have got k square z, so k square z, and y we got kz and its whole square, and denominator y is kz and z as it is and its whole square. Now take common here, kz is common, so kz you take common, so what is left here? K plus 1. Kz taken common, so 1k will remain here. Kz taken common, so only 1. Denominator only z is common, so you get k plus 1. So here you have whole square, here also you have whole square. So if you separate the power, so you get k square z square here into k plus 1 whole square, because when the product is raised to power, each factor will be raised to the same power. So k square z square k plus 1 whole square. Here also same process, z square into k plus 1 and its whole square. So this z square cancelled, k plus 1 whole square also cancelled, so eventually only k square left. Now take RHS. So RHS you are given, it's very simple, x by z only. You just need to put the value of x. So value of x is k square z, so k square z by z, z cancelled, so it is k square. So you see, here also k square, here also k square, so LHS is equal to RHS, so it is proved. Okay. Now we'll take the last question for today, that is question number 7, which came in the year 2015. So now this is also similar to question number 6 only, but there are it's slightly given in different way, so we can solve in another way also. So what is given is A, B, C are in continued proportion. Okay, so it's given in product form. So without using k also we can solve it. I'll show you that another method. So A, B, C are continued proportion, meaning this implies A by B is equal to B by C. This implies B square equal to AC. Okay, this is question number 1. Okay, now take LHS. So we start with LHS and try to get RHS using this relation. So we have A plus B plus C into A minus B plus C. That is LHS. So you can open the bracket here. A into A square, plus into minus, minus, A into B, AB, plus A into C, AC. So we multiplied by the first term. Now we multiply by the second term, plus B. Plus B into A is plus AB plus B into minus B is minus B square, plus B into plus C is plus BC. Now we multiply with the last term plus C. C into A is plus AC minus, because plus into minus is minus, B into C is BC, and plus C into C, C square. Now simplify here. Okay, so AB and plus minus AB cancelled, plus BC and minus BC also get cancelled. So you have A square, then AC plus AC will be twice AC plus C square here, and minus B square is there, plus C square. Okay, A square here, AC plus AC will be twice AC minus B square and plus C square. Now if you look at RHS, you have A square plus B square plus C square. AC term is not there. So we have found the value of AC here, which is equal to B square. So in place of AC, we write its value B square. So A square plus twice B square minus B square plus C square, using equation 1 where AC equal to B square. So we replace AC by B square, so 2B square. So A square plus 2B square minus B square is B square plus C square equal to right hand side. So this is proved. Okay, thank you class.